The requirement for ground fault circuit interrupter protection in non-dwelling bathrooms became effective with the 1999 National Electrical Code. Now, regarding non-dwelling bathrooms in buildings constructed before the 1999 National Electrical Code took effect, the installation is generally grandfathered in. This means that existing non-dwelling bathroom receptacles, both those within 6 feet of the sink and those not within 6 feet of the sink, do not need to be ground fault circuit interrupter protected unless an existing receptacle is being replaced. If an existing receptacle is being replaced, then the replacement has to be ground fault circuit interrupter protected. Only the receptacle within 6 feet of the sink does not need to be replaced with ground fault circuit interrupter protection unless it is being replaced. It is not required that all receptacles, both those within 6 feet of the sink and those not within 6 feet of the sink, need to be ground fault circuit interrupter protected unless being replaced. In existing buildings, the requirement for ground fault circuit interrupter protection in non-dwelling bathrooms is only triggered when an existing receptacle is being replaced. In this case, the replacement receptacle must be ground fault circuit interrupter protected. However, existing receptacles that are not being replaced do not need to be upgraded to ground fault circuit interrupter protection. Ground fault circuit interrupters, commonly referred to as ground fault circuit interrupters, are essential safety devices designed to protect individuals from electrical shock. They operate by monitoring the balance of current between the hot and neutral conductors in a circuit. Under normal circumstances, the current flowing through the hot conductor should be equal to the current returning through the neutral conductor. However, if a ground fault occurs, such as when a person comes into contact with a live wire, a portion of the current will flow through an unintended path to ground. This creates an imbalance in the current flow, which the ground fault circuit interrupter detects. When the ground fault circuit interrupter detects a current imbalance exceeding a predetermined threshold, typically 5 mA, it quickly trips the circuit, interrupting the flow of electricity and preventing a potentially fatal electrical shock. The speed at which a ground fault circuit interrupter trips is crucial for providing effective protection. Ground fault circuit interrupters are designed to trip within a fraction of a second, typically within 20 to 30 milliseconds. This rapid response time minimizes the duration of the electrical shock, significantly reducing the risk of serious injury or death. Ground fault circuit interrupters are commonly installed in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, laundry rooms, and outdoor locations. These areas are often characterized by the presence of water or moisture, which can increase the conductivity of electricity and make electrical shock more likely. In bathrooms, ground fault circuit interrupters are typically required for all receptacles located within 6 feet of a sink, shower, or bathtub. This is because water can easily splash or spill onto electrical devices in these areas, creating a potential hazard. In kitchens, ground fault circuit interrupters are typically required for receptacles serving countertop surfaces. This is because kitchen countertops are often used for preparing food and using electrical appliances, such as blenders and toasters, which can come into contact with water. In laundry rooms, ground fault circuit interrupters are typically required for receptacles serving washing machines and clothes dryers. This is because these appliances use water and can generate moisture, increasing the risk of electrical shock. In outdoor locations, ground fault circuit interrupters are typically required for all receptacles that are readily accessible. This is because outdoor environments are often exposed to rain, snow, and other forms of moisture, which can increase the risk of electrical shock. There are two main types of ground fault circuit interrupters: receptacle type ground fault circuit interrupters and circuit breaker type ground fault circuit interrupters. Receptacle type ground fault circuit interrupters are designed to be installed in place of standard electrical receptacles. They provide ground fault protection for the receptacle itself and for any other receptacles that are wired downstream from it in the same circuit. Circuit breaker type ground fault circuit interrupters are designed to be installed in an electrical panel in place of a standard circuit breaker. They provide ground fault protection for the entire circuit that they are connected to. When selecting a ground fault circuit interrupter, it is important to choose one that is rated for the voltage and current of the circuit that it will be protecting. It is also important to choose a ground fault circuit interrupter that is listed by a recognized testing laboratory, such as Underwriters Laboratories, to ensure that it meets safety standards. Ground fault circuit interrupters should be tested regularly to ensure that they are functioning properly. The National Electrical Code recommends testing ground fault circuit interrupters at least once a month. To test a ground fault circuit interrupter, simply press the test button on the device. This will simulate a ground fault and cause the ground fault circuit interrupter to trip. If the ground fault circuit interrupter does not trip when the test button is pressed, it should be replaced immediately. Ground fault circuit interrupters are an important safety device that can help to prevent electrical shock. They should be installed in all areas where there is a high risk of electrical shock and should be tested regularly to ensure that they are functioning properly. The National Electrical Code, or National Electrical Code, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is published by the National Fire Protection Association and is updated every 3 years. The National Electrical Code covers a wide range of topics related to electrical safety, including wiring methods, overcurrent protection, grounding, and equipment installation. It is intended to protect people and property from electrical hazards. The National Electrical Code is not a law itself, but it is often adopted by state and local governments as part of their building codes. This means that compliance with the National Electrical Code is legally required in many jurisdictions. The National Electrical Code is organized into chapters, articles, and sections. Chapters provide a broad overview of a particular topic, while articles delve into more specific requirements. Sections provide detailed instructions and specifications for specific electrical installations. Some of the key chapters in the National Electrical Code include Chapter 1 General, Chapter 2 Wiring and Protection, Chapter 3 Wiring Methods and Materials, Chapter 4 Equipment for General Use, Chapter 5 Special Occupancies, Chapter 6 Special Equipment, and Chapter 7 Special Conditions. Chapter 1 General covers the scope, purpose, and organization of the National Electrical Code. It also includes definitions of key terms used throughout the code. Chapter 2 Wiring and Protection covers the requirements for overcurrent protection, grounding, and bonding. It also includes requirements for conductor sizing and insulation. Chapter 3 Wiring Methods and Materials covers the requirements for various wiring methods such as conduit cable and raceway. It also includes requirements for electrical boxes, fittings, and supports. Chapter 4 Equipment for General Use covers the requirements for electrical equipment that is commonly used in buildings, such as lighting fixtures, receptacles, and switches. It also includes requirements for appliances and motors. Chapter 5 Special Occupancies covers the requirements for electrical installations in special occupancies such as hazardous locations, healthcare facilities, and swimming pools. Chapter 6 Special Equipment covers the requirements for electrical equipment that is used for special purposes, such as elevators, escalators, and electric signs. Chapter 7 Special Conditions covers the requirements for electrical installations that are subject to special conditions, such as emergency systems, standby power systems, and fire alarm systems. The National Electrical Code is a complex and comprehensive document, but it is essential for anyone who works with electricity. By following the requirements of the National Electrical Code, electricians and other electrical professionals can help to ensure the safety of people and property. The grandfather clause is a provision in many laws and regulations that exempts certain individuals or entities from the new requirements if they were already engaged in the activity before the law or regulation was enacted. The purpose of the grandfather clause is to avoid disrupting existing practices and to protect the vested interests of those who were already in compliance with the previous rules. In the context of electrical codes, the grandfather clause typically applies to existing electrical installations that were installed before the current version of the National Electrical Code was adopted. These installations are generally allowed to remain in place, even if they do not fully comply with the current code requirements, as long as they are not considered to be unsafe. However, if an existing electrical installation is altered or expanded, it must be brought into compliance with the current version of the National Electrical Code. This means that any new wiring, equipment, or devices must meet the latest code requirements. The grandfather clause can be a complex and controversial issue, as it can create different standards for existing and new installations. Some people argue that the grandfather clause is necessary to avoid imposing undue burdens on property owners who have already invested in electrical systems that were compliant with the previous code. Others argue that the grandfather clause can compromise safety by allowing older, potentially unsafe installations to remain in place. Ultimately, the decision of whether or not to apply the grandfather clause is a matter of balancing the interests of property owners with the need to ensure electrical safety. In many jurisdictions, the local electrical inspector has the authority to determine whether or not an existing electrical installation is safe and whether or not it must be brought into compliance with the current version of the National Electrical Code. When replacing a receptacle, it is important to follow all applicable electrical codes and safety regulations. This includes using the correct type of receptacle, ensuring that it is properly grounded, and protecting it with a ground fault circuit interrupter if required. The National Electrical Code specifies the types of receptacles that are permitted in different locations. For example, receptacles in bathrooms, kitchens, and outdoor locations must be ground fault circuit interrupter protected. It is also important to use a receptacle that is rated for the voltage and current of the circuit that it will be connected to. Receptacles are typically rated for 15 amps or 20 amps. When replacing a receptacle, it is important to ensure that it is properly grounded. Grounding provides a safe path for electricity to flow in the event of a fault. This can help to prevent electrical shock and protect electrical equipment from damage. There are several ways to ground a receptacle. One way is to connect the grounding wire from the receptacle to a metal electrical box that is grounded. Another way is to connect the grounding wire from the receptacle to a grounding electrode, such as a metal rod driven into the ground. If a receptacle is located in an area where there is a high risk of electrical shock, it must be protected with a ground fault circuit interrupter. Ground fault circuit interrupters are designed to detect ground faults and quickly interrupt the flow of electricity. This can help to prevent electrical shock and save lives. Ground fault circuit interrupters are typically required for receptacles in bathrooms, kitchens, and outdoor locations. When replacing a receptacle, it is important to turn off the power to the circuit at the circuit breaker. This will help to prevent electrical shock. It is also important to use insulated tools when working with electricity. Insulated tools will help to protect you from electrical shock. When replacing a receptacle, it is important to carefully follow the instructions that come with the new receptacle. This will help to ensure that the receptacle is installed correctly and safely. If you are not comfortable replacing a receptacle yourself, it is best to hire a qualified electrician. A qualified electrician will have the knowledge and experience to replace the receptacle safely and correctly. Electrical safety is very important. It's important to remember to always exercise caution when working with electricity.